Hello everyone, my name is Infantri Siahaan and I am a mechanical student from Udayana University. And right now I want to presenting about metallurgy topic with the title Testing and Inspection of Metals TUGAS for Quality. So the topic that we discuss in this presenting is metallography, harness testing, tensile testing, fracture toughness, impact testing, fatigue testing, and non-destructive testing. First is in introduction. Quality control of metal products is a marriage of the techniques of manufacturing engineering and statistical mathematics. Data must be collected in the form of either qualitative or quantitative measurements, which are then analyzed or evaluated. This process of quality assessment may be an informal exchange, or it may be a carefully planned program of sampling and statistical analysis. Another side, you can see what is quality control. Quality control is a process through which a business seeks to ensure the product quality is maintained or improved. Next is metallography. Metallography is the scientific discipline of examining and determining the constitution and the underlying structure or special relationship between the constituents in metals and alloys. The examination of structure may be done over a wide range of length scale or magnification level. The most familiar tool of metallography is the light or optical microscope with magnification ranging from 50 to 1500 times larger and the ability to resolve microstructural features of about 0.2 micrometer or larger. Hardness testing. Macro hardness testing. The first, macro hardness tests are commonly performed as an integral part of quality assurance procedure. In macro hardness testing, loads exceed 1 kg or about 2.2 pounds and the resulting indentation is visible to naked eye. Next is micro hardness testing. In micro hardness testing, loads are less than 1 kg force and indentation can be seen only with the aid of microscope. Knob and Vickers tests are in the category. Vickers indenter. The Vickers indenter is a square base diamond pyramid. The applied load force is generally 1 kg force or less. Second is knob indenter is a rhombus based diamond pyramid that provides an impression of the shape. Only the long diagonal is measured. You can see the form from the both indenter here. The left side is Vickers indenter and the right side is knob indenter. Just a different shape you can see. Next is tensile testing. Next to hardness testing, mechanical testing of specimen under tension is by far the most common type of mechanical test that is performed. The properties derived from tension testing include 3 points, that is, stress strain curves, tensile yield strength, and ultimate tensile strength or UTS. The cross-section of a typical gear-driven system is shown in this picture. Screws are rotated by a variable control motor and drive the movable crosshead up or down. This motion can load the specimen in either tension or compression, depending on how the specimen is fixed and tested. Screw-driven testing machines currently use of either a 1, 2, or 4 screw design. Next is fracture toughness. Fracture toughness testing. With the advent of linear elastic fracture mechanics, engineers now realize that the design of structures and machines can no longer, under all conditions, be based on the elastic limit or yield strength of a material. Various tests have been developed to measure the fracture toughness of materials, and these tests are generally conducted on test specimens containing a sharp, pre-existing crack. 5 different standard specimen geometries are specified in ASTM E1339, but most fracture toughness tests are conducted with either the H-notch, bend, or compact test specimen. Impact testing. In an impact test, a specimen is subject to dynamic shock loading to evaluate the response of a material to rapid change in loading, such as that experienced by an axle shaft when a car hits a crack hole. Fatigue testing. In general, fatigue normally consists of a crack initiation pass followed by a crack propagation pass. Three types of fatigue testing methodologies are commonly used, such as high cycle or infinite life, low cycle, finite life, and fatigue crack growth. Fatigue crack growth rate testing, based on the fracture mechanics concept of stress intensity. Next is non-destructive testing. Various non-destructive testing or NDT and inspection techniques are commonly used to detect and evaluate flaws, irregularities or discontinuities or defects in engineering system. Okay, this is non-destructive testing. So the first is liquid penetrant inspection. It is a non-destructive method used to find discontinuities that are open to the surface of solid, essentially non-porous material. The liquid penetrant inspection process is shown in this picture. A discontinuity open to the surface of a metal is located by following a penetrating dye or fluoroscant liquid to infiltrate it. Next is magnetic particle inspection. It's used to locate surface and subsurface discontinuities in ferromagnetic material. The method is based on the fact that when a material or part being tested is magnetized, discontinuities that lie in a direction generally transfers to the direction of the magnetic field, cause a leakage field to form at and above the surface of the part. Magnetic particles are applied over a surface either as dry particle or as wet particle in a liquid carrier, such as water and oil. The method of generating magnetic field generally is by using electromagnets. Various configurations are used. Electromagnetic yokes consist of a coil wound around a U-shaped core of soft iron. Next is radiographic inspection. Radiography is based on a differential absorption of penetrating radiation. Much like the X-rays taken at doctor's or dentist's office, three basic elements are involved, such as radiation source, test piece or object being evaluated, and a recording medium. Next is ultrasonic inspection. During ultrasonic inspection, beams of high-frequency acoustic energy are introduced into a material to detect surface and subsurface flows, to measure the thickness of the material, and to measure the distance to and the orientation of a flow. Last is eddy current inspection. It's based on the principle of electromagnetic induction and is used to identify or differentiate a wide variety of physical, structural, and metallurgical conditions in electrically conductive ferromagnetic and non-ferromagnetic metals and metal parts. In the eddy current method, the part to be inspected is placed within or adjacent to an electric coil in which an alternating current flows. The alternating current, also known as exciting current, causes eddy current to flow in the part as a result of electromagnetic induction. A flow such as a crack in a pipe causes a change in the characteristics of the flow of the current. For example, in figure below illustrates pipe travel along the length of the inspection coil. Okay, that's all I can presenting about this topic, and thank you for your attention. See you in the next topic.